Okay. So, the last section in Chapter 3, we're going to look at a new thing called linear inequalities in one variable. So, we're going to start looking at the first types of inequalities you'll see in algebra. So, they're very similar to solving equations. The only difference is that the equal sign is replaced with inequality symbols. And the idea is still the same as with solving linear equations. Get the variable by itself on one side and the numbers on the other side. The only difference is how we represent the solution set. So the solution set with an inequality is a set of values. It's a set of infinite values. And the way we describe that, we'll talk about in this section as well. Okay. So, when we're solving linear inequalities, there really isn't much difference, except there's one thing that students forget about all the time. And if you multiply, and that is if you multiply or divide both sides of an inequality by a negative number, the inequality reverses direction. So what that means is if you start off with less than or equal to, or greater than or equal to, and you multiply or divide by a negative number, it flips over. So, how do we solve this linear inequality? So this is greater than or equal to. So to solve this inequality, we just treat it as if though this were an equal sign. So you just solve it the same way you would solve an equation. So to solve this linear inequality, get the x's to one side and the numbers to the other. So I'm going to put the x's on the left side. So I'm going to subtract 8x from both sides. And I'm going to bring the number over here, so I'm going to add 2 to both sides. So when I do that, 8x's cancel, the 2's cancel. So 3x minus 8x is minus 5x, which is greater than or equal to 14 plus 2, which is 16. So now, if I want to get x, I just divide both sides by negative 5. Negative 5's cancel. Now, here's the thing. Since I divided by a negative number, this greater than or equal to becomes less than or equal to. This is going to flip because I divided by a negative number. So this is going to become this now instead. That's very important. And I just have 16, so this will be negative 16/5. That right there is my solution. So this means that my solution set is all the values less than or equal to negative 16/5. That's what this means. But we have a more definitive way to do this. We could represent this phrase with interval notation, which we're going to look at in this section. So on page number 2, so in words, here's all 4 different variations of a inequalities description. So this is x is less than 2. So that means anything less than the value 2 will be part of this inequality. Now it doesn't, so the difference between less than 2 and less than or equal to 2 is just we omit 2 here, but we include 2 here. So there's only a difference of one value, and that's the value 2. Everything less than 2 is included except 2. Here, everything less 2, but it also does include 2. So the interval notation is going to be from negative infinity, because this keeps going to the left forever and ever and ever in both cases. And it ends at 2 in both cases, but here we don't include the 2. Here we include the 2. So this is open here, it's closed here. That's the only difference. And it's the same thing for greater than or greater than or equal to, except we just go in the opposite direction. So this is interval notation, and it's pretty self-explanatory in the way we do it. And we could use interval notation to define an inequality solution set. And a way we could do that is we could make a graph or a number line to help us with that, but it's pretty straightforward. So let's solve this linear inequality. So the first thing you want to do here is distribute the negative 3. So you're going to get negative 12x. Negative 3 times negative 5 is 15. And then you're going to have minus 1. Less than or equal to 17 minus 6x. Okay? I can combine the 15 and 1, so minus 12x, that's going to 15 minus 1 is 14. Less than or equal to 17 minus 6x. Now from here, just get the x's on one side and numbers on the other. So I'll add 6x, and then I'll subtract 14. So that goes away. 14's go away. Negative 12x plus 6x is negative 6x. Less than or equal to. And 17 minus 14 is 3. Alright. So now, what do I do here? I have to divide by negative 6. Now, because I divided by negative 6, right, the negative 6 are going to cancel here. I'm going to have x. What do I do here? I'm going to flip this inequality. So this less than or equal to becomes greater than or equal to. What exactly? Negative 3 over 6 is, well, that reduces to negative a half. So x is going to become greater than or equal to negative 1/2. This is as an inequality. But if I want to graph it on a number line, it's really not that bad. So what I do is I include this value. So I always put 0 on my number line to separate positive and negative numbers. So negative 1/2 is over here. Now I'm trying to figure out of all the values that are greater than negative half. So that's everything. So anything that this is greater than or equal to right here. Greater than or equal to. So that means everything to the right of negative half. So everything to the right of that is going to be part of the solution set. Now what about negative half itself? Do I include it in the solution set? I do, because this is a equal to symbol. So there's going to be a solid dot at negative 1/2. So the interval notation so when you describe an inequality in interval notation, you always start with the smallest value. I want to sketch this shaded region as an interval. So I always start with the smallest value on the interval, comma, largest value on the interval. So the smallest value on this is negative 1/2, comma. Now the largest value is what? Well, this keeps going to the right forever and ever. So it's going to go to positive infinity. Now all I have to do is worry about the brackets. Are they going to be open brackets or closed brackets? Well, let me ask you this. Does infinity ever stop? No, it doesn't. It keeps going and going. So infinity is always going to be open. Now negative 1/2 is part of the solution set because of the equal sign. So because it's part of the interval, I'm going to put a closed bracket. And then that's it. That's how you describe this region, this inequality, in interval notation. This is the way you would describe the solution set. Just like that. So really, when you're solving linear inequalities, it's not much different than solving linear equations. The only thing different is the solution set is a set of values. That means any number in this interval will satisfy this inequality. Any number that's greater than negative 1/2. 0, plug it in here, you're going to get a true statement. 10, yeah, plug it in here, you're going to get a true statement. That's all it means. Whereas with an equation, a linear equation only has one solution. You only have one value. This is a set of infinite values. That's it. That's it. So on page 3, I have 2 more examples. I'll just go through them with you right now. So let's solve this. So again, I want to get the x's on one side. So to do that, I'm going to subtract 2/3 x and I'm going to subtract 4. Subtract 2/3 x and then subtract 4. So the 4's cancel, the 2/3 cancel. So 1/2 minus 2/3. I like to keep things as fractions because it's easier that way. So 1/2 minus 2/3 is, I'll make that as a fraction. Remember, go to math, enter on fraction, and I'll write it as negative 1/6. So it's negative 1/6 x is greater than 6 minus 4 is 2. Okay, so now what do I do here to get x? Well, this is dividing by negative 1/6, or I can multiply both sides by negative 6. Same thing. So if I divide by negative 1/6, right, to get rid of the negative 1/6, that's the same thing as multiplying this by negative 6. So now, because I divided or multiplied by a negative number, what this greater than becomes less than. So I'm going to have x is less than, right, 2 over negative 1/6, which I'll do my cat. So 2 divided by this number, so second answer, gives me negative 12. Alright, so on a number line, so I like to put 0. Negative 12 is over here somewhere to the left. And everything to the left of that, like this is less than, right? It's just strictly less than. There's no line under here, so it's not less than or equal to, it's just less than. So because it's less than, negative 12 is going to have an open dot. And everything less than negative 12 is to the left. So in interval notation, again, I want to represent this shaded region as an interval. So I guess I could have extended my number line a little longer just to illustrate that. Let me do that. Yeah, there we go. That's a little bit better. So what's the smallest value I could keep going? What's the smallest value if I kept going to the left? Remember, interval notation, smallest value, comma, largest value. So the smallest value, if I keep going to the left forever and ever, the smallest value is going to be negative infinity. And the largest value on this interval is negative 12. Now, remember, negative infinity, whether it's positive or negative, never stops. So it's always going to be open. And negative 12 is not part of this solution. It's open. So negative 12 is also going to be open. That's the solution set. That's it. That's it. That means I could pick any value less than negative 12, plug it in here, and I'll get a true statement. I'll get a number that's greater than another number. I'll get a true statement. All right. So, none of us like fractions, do we? So what I'm going to do here is, because this original problem has fractions in it, what I'll do is I'm going to multiply both sides of this inequality by a number to get rid of the fractions. So, alright, what number am I going to multiply? Well, if I think of common factors of 4, 6, and 3, so if I could think of a common factor that goes into 4, 6, and 3, I can multiply both sides of this inequality by that number to get rid of the fraction. You know, okay. So, is there, like, if I listed all the factors, you know, what are the factors of 4? Well, all right, 4, 8, 12, 16, 20, 24. What are the factors of 6? 6, 12, 18, so on. Factors of 3? 3, 6, 9, 12. Hey, look at that. So, what's a common factor they have? They all have 12, right? That's the lowest common factor they have. So, you know, 4 times 3 is 12, 6 times 2 is 12, and 3 times 4 is 12. So what I could do is, since they all have a common factor of 12, I can multiply both sides of this inequality. I can multiply this side by 12, and I can multiply this side by 12 to get rid of the fraction. And it'll make it much easier. You don't have to do that, but it's a good way to get rid of a fraction. So, alright, so now that I do that, if I distribute, so 12 over 4, I distribute that 12 now, so 12 over 4 becomes 3, and that's going to be multiplied by this 3x plus 5. In parentheses, because it multiplies the whole thing. Minus, you know, 12 over 6 is 2. times 2x minus 7. Less than. And 12 over 3 is 4. And 4 times 11 is 44. So now my fraction is gone, which makes things a little bit easier. So now distribute the 3, distribute the negative 2. So now I get 3 times 3x is 9x. 3 times 5 is 15. Minus 2 times 2x is minus 4x. Minus 2 times minus 7 is plus 14. Less than 44. Okay. Combine like terms. 9x minus 4x is 5x. 15 plus 14 is what? 29. Less than 44. Subtract 29 from both sides. So 5x is less than, so 44 minus 29 is 15. Well, that's nice. Divide by 5. So now, because I divided by a positive number, I do not have to flip this. I could keep it as is. 15 over 5 is 3. So again, number line. I like to put 0 there. So 3 is a positive number, so that's over here. Now everything, this is less than. So everything to the left of 3 will be shaded. Now, do I include 3 in the interval? No, I do not, because this is just strictly less than. So when I get to 3, it's going to be open. So my interval notation, what's the smallest value on this region? Keep going to the left forever, negative infinity. Comma, what's the largest value? 3. Does infinity never terminate? It does. It never terminates. So it's going to be open. And 3 is not part, so it's also open. That's it. That's it. So there's only one more thing left to talk about in this section. This is a pretty quick section. It's just solving linear inequalities. So sometimes you can have what's called a 3-part or compound inequality, which means you have 3 sides of an inequality. This just means x is going to be caught between 2 numbers. And that's really the only difference. So instead of having infinity or negative infinity on either side, you're going to have x caught between 2 specific numbers. That's it. Other than that, it's really not much different. So let me just show you a quick example on that, and that'll be it. So 2 is less than 3x plus 5, less than or equal to 26. So when you're solving this for x, what you do normally you would do it to both sides, and all you're doing is doing it to all 3 sides. That's it. So subtract 5 from all 3 sides. So I have 3x in the middle, less than or equal to, and less than. 26 minus 5 is 21. 2 minus 5 is negative 3. And now divide by 3 on all 3 sides. The 3's go away. X. So now because I divided by a positive value, I do not need to flip these. 21 over 3 is 7. Negative 3 over 3 is negative 1. There's my interval. This means x is caught between negative 1 and positive 7. So on my number line, I'll just include, there's 0, 7's over here, negative 1 is there. So this means x is in between negative 1 and 7, so that means everything in between. X is less than or equal to 7, which is everything to the left of 7, but x is bigger than negative 1, or negative 1 is less than x. So that's everything to the right of negative 1. That's this section. So do I include 7 because it's solid here. I have a equal to. So 7 is a solid dot. Negative 1 is an open dot. So finally, my interval what's the smallest value on this interval? Negative 1, comma, the largest value? 7. I include the 7, so it's a bracket. I do not include the negative 1, so it's open. That is it, ladies and gentlemen. That is it. Nothing to it. Again, when you have a 3-part inequality or just a regular 2-sided inequality, there's not much difference when it comes to solving these things. It's pretty simple. Now keep in mind, these are linear inequalities. If you take college algebra, you'll see quadratic and polynomial inequalities and rational inequalities. We're not talking about that in this course. But again, so that's it for this section, and that's it for chapter 3. And there's only one section in chapter 4 we look at. We don't do chapter 5 in this course, so yeah, so that's the last section in chapter 3 right there. Again, that's it. So yeah, so that's solving linear inequalities, and yeah, that's the end of the video.